For this video, we are going to prove that if the summation of the sequence is convergent, then the limit of the sequence as n approaches to positive infinity is equal to 0. So to start with our proof, let Sn be the sequence of partial sums for the given series, and the symbol S as the sum of the series, and that supposedly that the summation of an from n equal to 1 to positive infinity converges. Then the partial sums are this one. So we have Sn, this is the series, and the summation of the sequence. So instead of using n, we use I. Okay, again, instead of using n, we use I because we are going to get the partial sums only. So up until n only. So not until positive infinity. So again, we are going to include only sequence terms. Okay, we are going to include sequence terms in the summation up until n term only. Okay, up until n term. So we are not going to include the rest until positive infinity. So that is why this is just partial sum. Okay, we are just going to get the partial sums. Okay, so that is why we used I here instead of n. Okay, we used I here. And then from I equal to 1 up to n. So not until positive infinity. But anyway, whatever the answer here will also be the answer here. Okay. Now, there's another series here, but this time, the sequence that will be included in the summation is up until n minus 1, meaning less than 1 sequence term. Okay? In here, the summation of the sequence term is up until an. But in here, up until n minus 1. So meaning 1 less or less than 1 sequence term dito. Hindi na-include ang an. Okay? So again, this is the given equation, or this is the summation of Sn, and then this is the summation of Sn minus 1. Now, if we are going to subtract these two series, Sn minus Sn minus 1, we're going to subtract these two series, okay? So we can cancel this one because that will be equal to 0. Okay, and this one also, cancel, 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 at hanggang sa naiwan na lang ang an. Therefore, we can say that when we subtracted Sn and Sn minus 1, so that will be equal to an. Okay, so we were able to show this one. Okay, so let us get the limit of an. So when we get the limit of an, it would also mean that we will get the limit of Sn minus 1. And then we can separate the two quantities. So we have Sn. We can separate them into two quantities rather. So we have limit Sn and then the limit of Sn minus 1 as n approaches to positive infinity. Okay. Now, Based from the assumption that we have earlier, okay, based on the assumption that we have earlier that the summation of an that the summation of an is okay, we assume that the sum of the series is S. We have assumed that a while ago, that the sum of the series is S. And from the previous video, we have learned that the sum of the series is just the same as the limit of Sn as n approaches to positive infinity. Okay, they are equivalent. So the summation of if the summation of an is S, then it would also mean that the limit of Sn, the limit of the series, is also S. Kaya, in here, we have S. Okay? Because we have assumed that the sum of the series, ito na nga, the sum of the series is S. Okay? And now, bakit yung limit naman ng Sn minus 1 as n approaches positive infinity is also S? Okay, so take a look at this. So this is the summation of Sn. Okay, this is the summation of Sn. Now, this is equal to S. We assume that this is equal to S. Okay, wait. This should be yes, Sn. Okay. Now, if we are going to remove this one, and we will only add this one, so that will be Sn minus 1. Now, if from A1 to An we have S, then A1 up to An minus 1, we would also still have S, because it would only mean that the summation is getting the value of the summation as we add the sequence terms, it is approaching to the value S. Okay, it is approaching to the value of S. Okay, let me give you a specific example. Let's say we have 1/2 plus 1. Let's say, for example, these are already the partial sums. Okay, the sequence of the partial sums. So let's say we have Sn is equals to like this. So this is already the sequence of the partial sums. This is just an example. This is not exactly the ano. So let's say we have. So let's say this is 100 and this is 1000. Okay. Now, if you are going to convert these fractions into decimal points, then their value is approaching to 0. Okay, as we move forward to the sequence terms, and then convert the sequence terms into decimal points, no, then their value will be approaching to 0. Okay, it will approaching to 0. So ibig sabihin yan, yung limit ng Sn as n approaches to positive infinity is equal to 0. Okay? Pero kung aalisin natin yung, let's say, this is the An, meaning siya yung pinaka-last na n term, which is An. Kung aalisin natin yan, ano kaya yung magiging limit ng Sn minus 1? Minus 1 kasi inalis natin yung last term. Okay. So, ang ibig sabihin yan, ito na lang natira. Okay, for example. Ngayon, if we're going to get their values, still their values will be approaching to 0. 0 pa rin. Kaya, yung limit ng Sn minus 1 as n approaches to positive infinity is still equal to 0. Kaya we have S here. Okay? Because we assume that the limit of Sn is S. So, ganun din dito ang limit niya. S din. Okay. And then with this, we can say now, since this is 0, we can say now that the limit of an as n approaches to positive infinity is equal to 0. So we were able to show that we were able to prove that if the series is convergent, then the limit of the sequence as n approaches to positive infinity is equal to 0. Okay? So, again, if the series is convergent, then the limit of the sequence as n approaches to positive infinity must be equal to 0.